Okay, so this is what worksheet again, guys? 6A? All right, thanks. We introduced vertex form last week because we did that little earlier this week. Sorry, it's not last week. We did the little activity with the green and yellow cards. Remember, we talked about what you remembered about vertex form, and then we learned a little goofy trick Hofbauer had about how to graph without a calculator to find some points on vertex form, which if you can't do that, it's fine because there's other ways to find points, whether you do them by hand or you do them on the calculator. Today we're going to talk about all the forms of quadratics. The three forms we're going to talk about first here is polynomial or standard form, which is just like y equals ax squared plus bx plus c when it's all boiled together. That's standard or polynomial form. What letter's the same? The a is the same, right? It is not slope, but it is the rate at which it is increasing. It's just that it's not going in a straight line, so we can't call it slope. But this is the vertical stretch or shrink, and it is the same, okay? Even if we do some crazy transformation to move one form to the other, the a value will stay the same. All right. We're going to talk about different ways you could do this problem to find these three things, but let's just do the intercepts real quick. How do you always find x-intercepts? For what? Yes. Make y equal to 0. Okay, x-intercepts, you always make y equal to 0. So if I rewrote this as y equals 2x squared minus 4x minus 6, does a skill from the quiz come into play? How would you like to solve that? Okay, can we take out a 2 first? Divide out the 2 and throw it away because it's set equal to 0, so it's okay to do that. And then how will that factor? Factors, yeah, 3 is prime, guys. There's only 3 and 1. To get a negative 3, but add up to negative 2, this would be negative 3 plus 1 is negative 2 there. All right, and the two solutions, if we set it equal to 0, then our x equals 3 and negative 1. So I would really, really like you to practice writing these as ordered pairs. What are the x-intercepts? 3, 0, and negative 1, 0. Again, that reminds you we got them by putting the y equal to 0. All right, 3, negative 1. Y-intercept? Y-intercept, we just set x equal to 0. Yes, in this form, it would just be the c value. Yep. So if we plugged in a 0 here, we'd have 2 times 0 squared minus 4 times 0 minus 6, which is just negative 6. So the y-intercept is what? As an ordered pair. 0, negative 6. Okay. Now when we get to the vertex, there's several ways we could do this. One is obviously get our calculator out, right? And find the max or min, which is the vertex. If you are calculus bound, there is a portion of the calc AP test, close to half, that's no calculator at all. You have to be able to find the vertex using another form. You all, no matter who you had last year, learned what I like to call the vertex finder recipe. X equals negative b over 2a. We'll find the x of the vertex. Okay. It also finds the axis of symmetry. Okay, pretend that says symmetry. All right, so I kind of cut the problem off. Would someone remind me 2x squared minus 4x minus 6? Is that what it was? Okay. So x equals, what's the opposite of b? Opposite of negative 4 would be positive 4 over 2 times a, which is, do you need me to write that out more, or you get that it's also 4? I didn't write it out as, okay, just in case anybody's confused. It's the opposite of negative 4, which was the b, and this is 2 times the a, which is 2. So we end up with 4 over 4, which is 1. There we go. All right, so the vertex has an x value of 1. How do we find the y? This says axis of symmetry. Sorry, is that what I got you with my scribbling over there? I said pretend that says symmetry because, yeah, I knew it was messy. Sorry. If the x value is 1, to find the y value, we just have to plug the 1 back in. So we'd get y equals 2 times 1 squared minus 4 times 1 minus 6. This is 2 minus 4 is negative 2, minus 6, negative 8. Did anybody else get that? No? Anybody put the 1 in and get negative 8? Or did I do something wrong? Yes? Okay. Because this is also the axis of symmetry, we now know x equals 1 is the axis that goes down through the middle. I have a concept error I'm not sure some of you have ever figured out. And it's going to be very helpful with a different method here in a minute. When you have two x-intercepts, no matter where they are, okay? Oh my goodness. Pretend they're way over here. Pretend you're half asleep and your head is sideways, I guess. But what do you know about those two x-intercepts as related to the vertex? Yeah, the middle of those, the middle of the x-intercepts is always the axis of symmetry or the x-axis of the vertex. Does that make sense, guys? Wherever it's crossing, the average of them or the middle of them would give you the x. We're going to use that idea in a minute. We could have used that idea here, but the vertex finder recipe is important to know. All right, super easy sketch here, super bad probably sketch, but weird scale, we'll use that's -6, 1, -8, we'll call there, and we did a little sketch. Okay, could you find all those things and do all that for a parabola in standard form? Okay. The second one is our favorite, probably. Are you most comfortable with this form of a parabola?
Yeah.
Okay. Why are you most comfortable with this form? Okay, because we usually want to start with the vertex, and it's easy to pick out in this form. Oh, I was supposed to be writing H's and K's there. Whoops, sorry. So the vertex is at HK, which for this problem is what? -5 and -4. Anybody confused about that? You always have to take the opposite of what's in the parenthesis. That's true about a million things between here and the end of this course, that it's the opposite of what's in the parenthesis there, okay? It's true of circles, it's true of all kinds of stuff. All right. To find the x-intercepts, the rule was set y equal to 0. If I set y equal to 0, what is the easiest way to solve this? Remember what we did just yesterday on the quiz? Yeah, if we add 4 over here, we divide by this -3, but what happens when it comes time to square root? What's happening right there? It's not only irrational, it's imaginary, yes? Why? How can you have an imaginary number? Can you graph an imaginary number? What's happening? Does anybody explain why that happens on this one? The vertex is at -5, -4. Anybody know anything else? This means it opens down, doesn't it? Is it ever going to cross the x? That's why this came out imaginary, right? Because there are no x-intercepts. Tricking you on the second problem of the day. All right. What about the y-intercept? Does it have a y-intercept? Okay. Every parabola is eventually, that opens up and down, eventually going to get wide enough to cross the x-axis, right? Because, and the reason for that is any value for x, the domain is all real numbers, it can go in here. So therefore it has to cross eventually. Can we put in a 0 for the x and see what happens? -3, 0 plus 5 squared minus 4. -3 times 25 minus 4. Lovely, -79. Clearly that's on my graph paper, not. My joke third period was it just went onto the back of the paper by the time I went down 79. Anyway, okay. Any questions about vertex form? We're pretty happy with vertex form. It is not easy to find x-intercepts in vertex form. You would have to do this. It's not my favorite. If you're finding x-intercepts, what does this form look like? This is not vertex form. It's a pain in the neck to find the vertex.
But you have that.
But we do have the x-intercepts, right? This is factored or x-intercept form. Where are the x-intercepts? What about that half out there? Does that do anything to the x-intercepts? No, because if you set the y equal to 0, you'd have this. And remember, if we divide the 1/2 into 0, it's still 0. All right, so we found the x-intercepts. What about the y-intercept? Plug in 0 for the x, so we'd have 1/2 times 0 minus 5 times 0 plus 3. Half of this would be -15 over here, so we get a -7.5 or -15 halves. So it crosses down here somewhere at -7.5. Crosses over here at +5, and it crosses over here at -3. I'm just making up spots. But I still don't know the vertex. Two ways to find the vertex. One would be to foil this disaster back together and distribute it to 1/2 and use x equals -b over 2a. Does that sound like a fun way to do that? Not so fun. The easiest way of all would probably be to graph it on our calculator, but we're not going to do that. But what was the thing I just told you about a minute ago? Halfway between -3 and 5 is the axis of symmetry, right?
Yeah.
So how do you find halfway between -3 and 5? Which is 1. So x equals 1 is the axis of symmetry, which means it's what? 1 something for the vertex. Good job. So how can we find the rest of the vertex? Plug 1 in. Half of 1 minus 5 times 1 plus 3 is half of -4 times 4, which sounds like -8. So 1, -8 is the vertex. All right, so which form is your favorite? Well, it depends what they're asking, right? What if all I wanted was the y-intercept? Which one was the easiest for y-intercept?
First one.
Yeah, I would say first one. What if I wanted the x-intercepts?
Third.
This last one, right? Factored form? What's the one in the middle good for? Nothing. No, that's your favorite. It's the vertex, right? All right. Here we go. Changing from one form to another. So the first one says change this to x-intercept form. What does that mean? What else is x-intercept form called? Factored form. So all we want to do is factor this. How does that factor? The factors of 5 are only 5 and 1. So that's the only way it can factor. But to get a negative 6 in the middle and multiply to make positive 5, they need to both be negative. Now if we had to find the vertex, it would be in the middle of those x-intercepts. But that's all it has to do. That one was easy, yes? Okay. Change to vertex form. 2 ways you can do this. Ideas? All right. One is to find the vertex. I'm going to suggest by using x equals negative b over 2a. You could use the calculator as well. And if you do it that way, you have to keep any stretch. Which on this one is 1, but on this one is 2. Okay? The other option is completing the square. I don't know how many of you love completing the square. Actually, I would probably do completing the square on this one and not completing the square on this one. Does anybody know why completing the square is a whole new animal on the second one? Because of this 2 out front. Okay? I'll show you how to do it, but I'm not going to think that would be your first choice. All right. If we complete this square here, you'd have to do what first? Move the 1 over. So you'd have y minus 1 plus blank equals x squared minus 4x plus blank. Then what? You take half of this as x minus 2, and you square it. Now, this is where some of you are totally confused, and you think I'm doing magic. Completing the square is not magic. Look, this is what some of you are doing. You're putting a plus 4 back here. You don't need a plus 4 there because x minus 2 times x minus 2 is x squared minus 4x plus 4. It's already equivalent, okay? Do you understand that that factors to be this? That's the whole point. All right, whatever went in that blank has to go in this blank. This becomes y plus 3 over here. If we subtract the 3 over to the other side, we get x minus 2 squared minus 3. Did I lose anybody? That was completing the square. The other method would have been to take this and do x equals negative b over 2a. Can you humor me? What's the opposite of b? 2 times the a value would just be 2. So we got 2 for the vertex. How do we find the other piece of the vertex? Plug it back in. 2 squared minus 4 times 2 plus 1 would be 4 minus 8 is negative 4 plus 1 is negative 3. So my vertex is 2, negative 3. And then I could have said, well, I know vertex form. It goes a x minus h squared plus k. And the a value I have to keep in there, but it was a 1. Did that do the same thing? Okay. Now, C, for part C here, my choice would have been first choice probably would not have been completing the square. So I'm going to show you x equals negative b over 2a. No, we're trying to find the vertex. We're not trying to find the zeros. Otherwise, you'd be doing quadratic formula. But to find the vertex, okay, what's negative b? Over twice the a value. So we get 3. So the vertex starts with a 3. Then if I do 2 times 3 squared minus 12 times 3 plus 7, this is 2 times 9 minus 836, just kidding, plus 7. 18 minus 36 is negative 18, plus 7 is negative 11. Could have done all that in your calculator. Now, how would this look in vertex form then? Anthony's just future math team member. The words out of his mouth were, you can't forget the 2. There still has to be a stretch of 2. Even though we rewrote this in vertex form, there still has to be the stretch of 2 out there, okay? Now, don't write this down. If I FOIL this together, I get x squared minus 6x plus 9. If I distribute a 2 through there, I get 2x squared minus 12x plus 18. 18 minus 11 is 7. Did I get back to what I started with? Okay. I'm just trying to show you that it's not magic, that keeping the 2 really is necessary to get back to what you started with, okay? All right, that's the way I would have done that problem. I'm going to review completing the square with a 2. Anybody know how you do completing the square with the 2 out there? You still have to subtract the 7 and put a blank. But on this side, you have to factor out the 2, so we'd have 2. I got rid of this already. If I took a 2 out of this, what would I have? X squared minus 6. I'm just doing this little piece right here. X squared minus 6x plus blank. Does this equivalent to what we started with? 2x squared minus 12x, and it had a plus 7 over there, right? Okay. You take half of this still. What does that become? X minus 3 squared plus 9. The problem is you can't put a 9 over here. Why not? 2 times 9 is 18, so we really added 18 to that side, which makes this 11, and then we subtract the 11 over here, and we get vertex form. How many of you are going to choose to complete the square with a coefficient other than 1? Probably nobody, right? Vertex finder you could do, though? What's the trick when you use vertex finder? You still have to keep the stretch. Nice. Joey gets an A for the day. Let me put that in the grade book. All right. So help me with these quickly. What's the vertex on A? 5, 6. It asks for the line of symmetry. It is always, oh, there, I can't write that apparently. Symmetry, there's too many little bumps there, okay. X equals 5. It's always a vertical line through the X value of the vertex. What direction does this parabola open? It opens up, and it would be skinnier or wider than one that didn't have a 2. Yeah, it would be skinnier. What else do they want us to find? Sketch the graph. This is going to be the smallest graph ever. Okay, I'm going to go over 5, up 6, and it would open up. That's my little baby graph. All right, what about B? Easy, not easy? Still easy to find the vertex? Axis of symmetry, anybody? Which I didn't draw on this. It didn't say you had to, but it would cross at 5. Okay. This one has an axis of symmetry of x equals -3. So if we were doing the graph, it's left 3 and up 7, and x equals -3. But something else is a -3, right? The leading coefficient here, which means that it opens what? Yes, it opens down and is narrow. All right, this one's not our favorite because it's not in that form. How can we find the vertex? Negative b over 2a would become what? Positive 6 over 4, which is 3/2 or 1.5. I'm not taking your calculator away. You can put the 1.5 back in here. To find the rest of the vertex, you need 2 times 3/2 squared, or 1.5 squared, minus 6 times 3/2 plus 13. Don't write this down. Just do it on your calculator. I'm just trying to do it in my head. See, even in my head, I switched to decimals. 8.5 or 17/2, anybody? No? Did anybody type it in their calculator? Did you get 8.5? What? Either one is fine, right? I don't care. You can write the vertex as either 1.5, 8.5, or it is equivalent to 3/2 and 17/2. I don't care which way you write it. As long as it's exact, we're good. Axis of symmetry. X equals 3/2. If we graphed it, it's over 1.5, up 8.5, and doing what? Still opening up and skinny. My graphs get smaller as I wish. Questions? All right. Yes. You're okay? All right. I didn't quite hear what you said, but as long as you're okay, then I'm... All right, guys. The gold sheet is wrong. The assignment for this section, I want to change a couple of the numbers. These are the questions I want to assign, okay? And it says, like, I don't know what it says, but these are the ones I really want to assign. But honestly, tonight, the only ones you can do are 7 and 11. My suggestion would be that you practice doing 7 through 12 all, but 7 and 11 are all that are required. You can't do the rest of this yet. You don't know how. Well, you might, but... Okay, 7 and 11. 2 homework problems. I think you can handle it. It says 7B. Yeah, I changed it. I want it to be 1, 6, 7, 11. The original ones, a couple of them were really hard, and so I just tried to make it more equal to what I would put on a test or quiz. I didn't key it before I made an assignment. I know, it was bad. Then I keyed it and I went, oh, I shouldn't assign those. Oh, yeah. Is there something I can help someone do a complex number question, do a quadratic formula, talk about discriminant? Jada, here's your pass. Nina, here's your pass. Alex, here's your pass. Anthony, here's your pass. Albert.
Okay, so I forgot to put in the packet
Okay, okay. I'll just put that in so that when I come to a parent conference later, I don't go, you didn't do the worksheet most likely, because you obviously did, so. It's not worth points, but I don't want to misrepresent what you did. Does that make sense? I'll fix it. Can I keep it for now? Okay. Anthony, here's your pass. When is it? Yes. I was just confused because I don't know how 2 over 2 is the same as 2, but. And it was negative, so then the 19 would be right. Yes. So just come in and I'll just make you do one of those problems and show me you can do it right, okay? And maybe one of those problems because you made a little mistake. But you don't have to do a bunch of remediation. Did you want to do it today or no? Yeah. You wait till next week and you won't be upset? Okay, thanks. Yes, honey, help yourself. What's up? What are you wanting to retake? Sure.